Okay, so direct your attention to the screen and let's do this. I strongly suggest you write down on the sheet where I provided the space the correct answer. Rocket-powered grenade launcher launched the grenade vertically upwards. 18 seconds later, the bullet has a velocity of 60 meters per second downward. I apologize for the change of projectile. So once again, here the time is 18, and the velocity would be minus 60. Now, a lot of people have asked me, what's the initial velocity? Well, isn't that what they're asking you in part A?
236.4.
Right? You also know that at this point right here, the peak, I'll call it VF, the velocity is 0, is it not? Goes up, goes to 0, and then it comes right back down. And this D here is what we're trying to find, and the acceleration is minus 9.8.
Isn't the 60 VF?
The 60 is a VF, but it's a VF for the 0 to 18 time period, right? Okay, so I would suggest, let me see here, we've got Is this going to get us anywhere?
I will. Get it. I did it wrong apparently.
We don't know what. I can't find. I need delta V.
You might as well do that.
All I know is that's 18, right? I'm getting kind of worried here. I just pulled this question out. Well done, group. Okay, so we know. What was the first step? Minus 9.8 in for the acceleration.
Equals delta V over 18.
Yes, solve for delta V. So delta V is equal. Okay, Lucas, now is the point where you listen, so you learn how to do it. Minus 176 point what, Kia?
4.
Okay, good. So the velocity will change by minus 176.4 over that 18 seconds. And then her next step was to do this.
Yep.
Right? So minus 176.4. The final velocity is?
Why is it negative 65?
Because that 60 is on its way down.
Oh.
You're solving for the initial velocity. Okay, so now, because this is negative VI here, I want positive VI, right?
So you switch sides.
Switch sides, Nate? Okay, so that minus VI goes to the other side and becomes
VI.
positive VI.
And equals.
That's minus 60 still, but now that 176 goes over and becomes positive. And so you get 176 minus 60, or 116.4. That, my friends, is the initial. You got your group got that, Nate?
Yeah, we're gonna get
Any other groups get that? You got 0. It's definitely not 0 because it's got to go up, right? Okay. Oh yeah. Okay. Should I give you 2 minutes to do part B now? I'm giving you 2 minutes to do part B. Solve part B. Go. Nick, solve part B. Lucas, solve part B, please.
I get it really quiet. Sorry. Because barely everybody said we got it right.
We got the delta V or change velocity. Look at Stay up here.
Lucas and Nate.
I didn't say anything. Sure, trust me. Any girl, especially that guy, you're supposed to know it.
You know?
He's like, Nate, stop talking. It's not. I still got 88.2, so it's good ride. You plug in and say it's 60 positive now, it's so upwards, and it's still giving you.
All right, so part B, how long does it take to reach its maximum height? Now we know,
V-bar.
this is part B, delta V is going to be VF minus VI. No, this is a different delta V, right? Because here the final velocity is 0. The initial velocity was 116.4, and so it shouldn't come as any surprise that the change in velocity is minus 116.4, and we want to know the time.
What is the time?
Solve for T.
Why is final velocity 0 now?
Because when it goes up at that instant right there, right at its peak, it's not going up or going down. Its velocity is 0.
Oh.
Walk off stage.
11.9, which was pretty close to what we estimated, right? Got that one?
Yeah.
All right. Okay, part C, go. 2 minutes.
Oh, I just wanted to bring that down.
Yeah, I was trying to copy that, and it was like off the board. I said I had to follow. Wow.
Hey, we did.
Okay, so part C asks for what? Part C asks for the height, right? Okay, so the formula that's got D in it has average velocity in it, right? So I don't have average yet. Initial plus final divided by 2. Nate, what's the initial velocity?
Definitely negative 1/6 now, and then
Negative 1. No, it's not negative, it's up. 116.4 plus 0 at the top divided by 2, which is
How do you even know when to reach?
58.2, right?
What the hell?
So now that 58.2 goes over here. D, the time is 11.9.
So gross. Disgusting.
692.6 meters. Anybody get that? Yeah? Good. Okay, so question number 2. 70 kilograms is our mass. And he's slowing down as he approaches the ground floor. So here's the elevator, near the bottom, right? And as he's slowing down, get to the bottom, what happens? You feel heavier. You feel heavier. So, the apparent force on him, the apparent weight force, is equal to his weight force plus the deceleration, right? So this is going to be 70 times 9.8, but that 9.8 is really what? Direction. It's not like down, it is down.
You like down?
I like down.
And Willy Wonka's chocolate factory goes all
Okay, so that's going to be, get a calculator here.
You ever seen it? Like those?
Okay, yes, I've seen it, Lucas.
You're like flies, like how does he do that?
It's just a fictional movie, you realize, right?
No.
It's not a documentary. Minus 686, this is going to be minus 112, and when you combine them together, you get minus 798 newtons. But the question says, what does the scale read in kilograms? The scale thinks his weight force is minus 798. You're solving for the mass. Does his mass actually change? No, it's just fooling the scale. And you get 81.4 kilograms, which I saw several groups get.
The first time we did it, we got to
Okay, that's fine. All right, so you've got a little time left. There's lots of problems in this package right here. I'm going to borrow Nate's. Okay? I think I've shown you that you still need some practice. Right? Take the time and do the practice. The solutions are there, the code is there, the answers are there, the solutions are here in a binder. Use them, please. Okay? You'll have a little more time to work tomorrow. I'm going to talk about, tomorrow we're going to do the old dig the hole through the center of the earth talk. And then you'll probably have about a half an hour to work on problems as well tomorrow.
So we can have a big old
Big old piece of paper can go on the recycle.
Hey, you said it's worth 5 marks.
I never said that. I said that on there.
All right,
I lied. I just used it in a different way this time around, that's all.